Welcome to statistics. Today we are going to look at what we call Bi-Variate. Bi-Variate or regression. Bi, this means two. And then variate is variables. So in other words, we are going to be dealing with data that involves two variables. Data that involves two variables. Maybe for simplicity's sake, we can say data with x and y. Just like at O level, the equation of straight line was y equals mx plus c. We know that from our previous level.
Yes.
This is the equation of a straight line. So there are cases whereby we are collecting two sets of data. Maybe it's a class of mathematics or a class of sciences, and maybe we wrote two subjects, mathematics and chemistry, and we have got 10 students, and they've got a mark for mathematics, a mark for chemistry, mark for maths, mark for chemistry. If we try to analyze the trend which that data follows, that's what we'll be dealing with here. Like, we can have cases whereby we are saying the amount of rainfall that is falling within a particular farming season compared to the harvest to be expected within that year. Those are two things that we are comparing: rainfall versus yield. So in this topic, we are going to deal with two variables, and the line that best describes the trend that is being followed is called the line of best fit. Line of best fit. And its formula is y equals to beta naught plus beta 1 x. Like this. So we can have, if we plot, maybe these are marks in chemistry and maths, as I was saying, maybe you discover that if we put them on an xy plane, this is our y, this is our x. Maybe this is maths, this is chemistry, and they are like this, like this, like this, like this. You see, these points are not following any order. So the relationship between these two is very minimal. In other words, for us to say we know your mark in chemistry, then we should estimate your mark in mathematics. We will be biased. Because these two, the relationship is weak, as shown by the scatter plot. This is called a scatter plot. If you plot your points and they are just all over the shore, they are not following any trend, we call that a scatter plot and with a weak relationship. Okay?
Yes.
So, we can have a situation like, maybe this is math, this is chemistry. And if you plot the marks, the one for math against the one for chemistry, maybe they're like this. Can you see that? Now there is some direction in which our data is going. So this is a trend. So we put a line to describe that relationship. If the line is positive, like this, the gradient for such a line is positive and the one that goes right is negative. If this gradient is positive and the line is almost like sharing those points equally, there is a strong relationship. Strong positive relationship. Between these two that we are analyzing. Also, we can have quadratic relationships. The ones that go like. Of course, not perfectly quadratic. This relationship is not perfect. If it's perfect, all the points should follow or fall on the straight line. But because there is a certain trend, we try to establish a line that best shares the points and minimizes the error. Okay, so now we are saying poor relationship, strong positive relationship, and if it's like positive, perfect. If it's like this, it's perfect. All the points are on a straight line, which means you can perfectly estimate chemistry using maths or maths using chemistry. So, I want to, this is where the graph cuts, where the line of best fit cuts the y-axis. And this is the gradient of the line of best fit. Okay? Alright. So now, just bear with me, let me clear here. When we're doing regression, it's not always that we deal with two variables. We can deal with 5 or so, multivariate, whatever. But in this case, for bivariate, we're only dealing with 2. So now, what we are saying is, we need to establish the strength of a relationship for us to be able to say, this relationship is strong, weak, or there is no relationship. If there is no relationship, then there is no need for us to write that y equals to beta naught plus beta 1x. Because that line, that equation, it enables us to estimate the other variable given the other. In case we lost the mark for chemistry, we want to estimate it using what that person got in mathematics. So we first have to say, is there a relationship? And how strong is the relationship? That's what we call correlation analysis. So now, strength of a relationship. This is determined by R. We call it R. Okay? So, that R should always lie between, R should lie between -1 and 1. If it's -1, it's a perfect negative. Perfect inverse relationship. If it's 1, perfect positive relationship. Alright. If, say it's 0, 0 implies no relationship. Maybe around 50, which is 0.5. And its neighborhood, we're saying around, thereabout, not precisely 50%, but as long as it's 0.5, we call that relationship a moderate relationship. It's in between. There is a relationship, not very strong, not very weak, but it is there. Around 80% you can say there is a strong relationship. So R now, how do we calculate R? Alright. R equals to N summation of xy minus summation of x summation of y all over square root of n summation of x squared minus summation of x squared square root of n summation of y squared minus summation of y, all this way. That's your value for r. But r should always lie between minus 1 and 1. So now, never mind the length of the formula, it doesn't matter. Don't worry. You can also calculate it by other means, but basically let's deal with this. But never mind the formula, never mind, it's okay. When you are given an exam or any situation, you will be given this formula, but however, for efficiency's sake, you should not. Alright, so what I'm saying is, if your R, you calculate your R, even some softwares, mathematical softwares, can calculate for you the R. You say recall R, after entering data, it will show you what the value of R is, between minus 1 and 1. Alright, so we are saying this is R. Let's now go to what we call R squared. R squared is called the coefficient of determination. In other words, if you get R, say your R is 0.9, it simply means, say, R equals to 0.9. It implies that R squared equals to 0.81, which is equals to 81%, which is a strong relationship. In other words, you define the strength of your relationship here. 90% is a strong relationship, isn't it? So when you square R now, what it means, amount of rainfall and the yield. So now, when you get this to be your R squared, it means 81% of the variability in yield can be explained by the amount of rainfall in that particular season, leaving the other 19% to be explained by other factors. Don't be confused. What I'm saying, this is the percentage that you get for R squared. It means the regression equation, which was y equals to beta naught plus beta 1x, which is y equals to mx plus c, can only explain this percentage of variation in our yield. Which means when we are saying we are estimating rainfall using yield or what, it simply means 81% of the variability in yield is attributable to rainfall. 81% of the variability in the dependent variable can be explained by the regression equation, leaving the other percentage, which is 19%, to be explained by other factors. Maybe this is to do with the training of the agriculturalists. Maybe this is to do with also soil texture, which we didn't capture, because in this research we are only capturing yield and rainfall. So there are other things that usually ultimately causes yield to be different. Yet we are saying there is a relationship, but not all the variability can be explained by y equals to beta naught plus beta 1x. Okay? So there are some situations. Okay, this is R. So I said, now we said y equals mx plus c, y equals to beta 1x plus beta naught. Can you see that? Yes. A regression equation can be said to be y on x. When we are saying y on x, it means we are using y. So we are using x to determine the value of y. In other words, that regression equation it's like x on y is like. It's one and the same thing, but what varies is the direction. So when we are saying y on x, y minus y bar equals to x minus x bar. If you simplify this form, you get to them. So in other words, you need to calculate y bar, which is the mean. The mean of y, the mean of x. Can you see it?
Yes.
And then the gradient. You substitute, you simplify, you get that. If it's x on y, I will explain the x on y and y on x. It's x minus x bar equals m x m1 x y minus y bar. But can you note one thing here? Here our m here m equals to n summation of x summation of xy summation of x summation of y all over n summation of x squared minus summation of x. Can you see that?
Yes.
And here m1 equals to n, the top part is the same. I think you can see that even for r. N summation of y squared minus summation of y. Like that. So this is x on y, this is y on x. Everything else is the same. Alright, for example, let's have an example. I'll give you an example and then we do it and we are done. Alright, I will have a table here. This table, I'm going to do two variables here. Advertising expenditure against sales. Where we are saying, we are putting money to advertising as a company. How much sales are we getting after putting a certain budget towards advertising? So now we've got two variables, that is advertising, advert. In thousands there, let's put it in thousands. And sales, our sales there, in thousands. Sales value. Okay, can you give me the figures on that table? 1.5 against what?
30.
What's the next?
3 against 18.
3 against 18.
12 against 37.
12 against 37.
7.5 against 23.
23.
2 against 3.79.
3.79. Alright. So these are the figures that we have. In other words, when we used $1,500, is it? $1,500, we realized sales of 30,000. When we used the 3,000, we realized the sales of what? Of 18,000. 12,000, 37. Can you see that?
Yes.
Now, what we are saying is, question now, on this table, the question is, calculate R and interpret R and R squared. That is item A. Item B. Calculate the amount of sale of advert required to reach sales of $50,000. These are dollars. And explain why this is. Okay? And explain, so if is the proper way. Full stop. Also C, calculate y on x. Full stop. Now, alright, this is the question that we have. We've got adverbs, we've got cells. So we want to know how much money to put to reach a certain level of cells. Alright, the starting point, you take your calculator, scientific of course, DAL 531, EV or whatever calculator that you have. You enter this data, you go where there is mod, the mod button on your calculator. If you press mod, it will give you several options, and on those options there is statistics. On some they go straight away to line, you go for option line. On other calculators you go for option statistics, which is option maybe 2 or 1. If it's on 2, you press 2. If it's line, you press on the number that is represented by line. If it's line is on 1, you press 1. And then it will give you, automatically it translates to the statistical mode. And once it translates there, you punch 1.5. There is a button there with a separator, comma, semicolon like. You punch it 30. And you say mode, data. There is a button of data there. It captures until you get to the end. Alright. Once you enter this information into your calculator, you will discover that how many 1, 2, 3, 4, 5. So we've got our n equals to 5. What is n? The number of times we did these observations. N equals to 5. That's the first thing. Your summary of statistics. Summary of statistics. It's not in the rigorous way of calculating, because now there are softwares that do that. So you can just straight away use your calculator to go for summaries. So the first summary is summation of x. What is summation of x from your calculator? Recall sum of x.
26.
26. Summation of y. What's summation of y on your calculator?
111,79.
111,79. Don't say 111. It's 111, comma. It confuses. All right. Summation of xy. What is summation of xy? In other words, we are saying this times that plus this times that plus this times that.
723.08.
0.08. Thank you. What is summation of x squared?
215.5.
1.5. What is summation of y squared?
3136.3641.
Like this.
Yes.
Alright, so this is your summary of statistics. This is statistics that you are going to use for you to be able to answer the question. So we are now saying part A. We are now on part A. Part A. Calculate error and interpret it. We said error, it talks of the relationship. N summation of y like this, all over n summation of y squared minus summation of y squared, square root of n summation of x squared minus summation of x squared, which is equals to, you just come and you substitute your n is 5. Summation of xy is 723.08 minus summation of x 26, summation of y 111.79 all over square root of 5. Summation of 3136 squared, not squared, minus 111 squared, etc. What is the answer? Recall R on your calculator there. Some R, there is some R somewhere.
3136.
No, it's not possible. It's not.
0.7.
Exactly, we're not talking.
5,
0.7,
250.
okay,
75.
which is close to 72.5%. Which means there is a strong positive relationship between advertising and sales, as shown by 72%. That's the strength of the relationship that exists between these two. Alright, from there now, where do we go? The amount of advert required to reach that sales. In other words, what they are saying, if we say this is our X, did we say this is X?
Yes.
This is Y. Alright. Mind you, when you are dealing with variables, X is the independent what? Variable. Sales are depending on advert. It's not advert that depends on sales. Do you get that logic?
Yes.
Yes. So if you are asked to draw a scatter plot, your horizontal axis, you put what? Advert. And on the vertical axis you put. So they are saying sales. If sales are 50,000, if Y is 50,000, what is X? That's this question. If Y equals to 50,000, what is X? Full stop. We are simply saying, so which means we have to calculate that equation, which is this equation. So once we calculate that equation, we can now go where there is Y and put what? 50,000 in order to get what? X. But there is a question, and explain if this is the proper way. It's improper in the sense that we are using a dependent variable to explain an independent variable. Advertising is an independent variable. Sales is dependent on advertising. So we cannot estimate advertising expenditure using sales. We cannot estimate X using Y. But Y can be estimated using X. Alright. So now, the regression equation Y on X. Y minus Y bar equals M X minus X bar. Y minus, what's Y bar? Summation of Y over N is there. What's Y bar?
18.63.
18.63. X bar?
4.33. 33.
What about M? M, you just use that formula, but on your calculator is there, you recall. You put the formula, substitute everything, and so that you'll be training yourself how to do it. But it's there on your calculator. So now Y minus, what's that? 18.63 equals to 2.32 X minus, what's our X bar? 4.33. If you simplify this, what do you get? Y equals to 2.32 X plus what? So that will be your plus some value here, some C, which you can get there, or beta naught. 10.0456. It's okay. So now this is the regression equation. So now I want you to explain R and R squared. Did we explain R squared?
No.
No. R squared now, we say this is R. What's your R squared then? 0.9?
Yes.
0.553, which is equal to 53%. It's not very strong. In other words, 53% of variation in one. What is what? Cells. Explained by the regression equation. Leaving the other 47.
37.
Is it 37? 47. Leaving 47.
37. It's 47.
Leaving 47% to be explained by other factors. Factors which are not captured in these two. Maybe the ability of the salesman to do his duty. We can have products well advertised, but sometimes they are not delivered to all possible outlets. Sometimes there are some crises in the country where sales are limited because of those things. So all those other things which are not sales in advertising, they come within this 47%. So that's Bi-Variate analysis. You simply need to compare two variables, and before you go further, you need to know which variable depends on the other. And if you are estimating, you should know that you can't estimate an independent using a dependent. It's impossible. You are violating a mathematical principle. So this is Bivariate.
Hi, my name is Mavis Moe. I live in Koba 18. I'm a lower 6 student at Regina Mundi. I have attended the Maths Clinic twice and I have found it to be of benefit, especially in solving concepts, in trigonometry, induction, etc. If you're a 6 student in mathematics, then you need the Maths Clinic. Thank you.